Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Clueless Jigsaw Sudoku 3 by Alf Smith. And here are the rules. This is what he calls normal jigsaw Sudoku rules apply. But this is, to me, just normal Sudoku rules, where in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which in this case are not boxes. They are just 9-cell regions, right? So this is a 9-cell region here, and this is why I talk about they are in designated 9-cell regions, because all of these are designated 9-cell regions here, right? So this is, to me, just normal Sudoku rules. We have, and the other rule, essentially, or the other set of rules, is a gold cell contains its position within its row, column, or region in normal reading order. So, for example, the gold cell row 4, column 7 contains either a 7, which is position in the row, right? So this is 1, 2, 3, 4, 5, 6, 7th position in the row. It could be 4, which is its position in the column, which is 1, 2, 3, 4, or 3, which is its position in the region, right? 1, 2, 3. And this is normal reading order, is typical Western reading notation, which means it goes from top to bottom and then left to right. So this would be position 1 because it's the topmost cell and topmost row and then the leftmost cell. So this would be in this region, it would be 1, 2, 3. This is 4, 5, and 6, and this is 7, 8, 9. In this region, it would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because it's normally, again, it's from top to bottom and then left to right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be, in this region, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9 is the counting in the region. And that's that rule set. And then all possible gold cells are given. So this is the negative constraint in place. So if it's not a gold cell, for example, the white cell, excuse me, the white cell in row 9, column 5, does not contain a 5, which is its position in the row, a 9, which is its position in the column, or a 8, which is its position in the region, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So because it's white and all gospel gold cells are given, this cannot contain the restrictions that would normally have for a gold cell. So cannot contain the digits that a gold cell would normally have because we know it can't be gold. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Interesting thing is, if a gold cell is the only cell in its row or column, it has to match that row or column number. Because in every row, you're going to have a 1 through 9. And so for row 1, you have to match somewhere in that row. Same with column number, right? If you have a 4, so this is the only gold cell in column 5. Well, you're going to have a 5 somewhere here, and that matches the row positioning somewhere. Well, that means it has to be the gold cell. The only gold cell in that column. So this is a 5 guaranteed. So we're guaranteed a 4 here, a 3 in one of these 3 cells. A 2 has to be one of these cells. So in this region 7, I guess. Yeah, it's region 7. In region 7, the 2 has to be one of these 3 cells because it's the only cell that matches in column 2 for gold cell. So then the 2 has to be one of these. Same with the 8. 8 has to be one of these 3 cells in row 8 because there's none of these are matching, so none of these can contain an 8, which forces an 8 to be here. So the 8 in region 7 has to be one of these 3 cells too. Region and row 2, we also have a similar thing. One of these is a 2 because the 2 cannot be in the white cells because it would be matching its column number. Sorry, its position in the column, right? So one of these must be 2. So row 1 has to be one of these 3. There's no restriction there. 2 is one of those 2. 3 has to be one of those 3. 4 has to be one of those 4. Row 5, this has to be a 5. Because that's the only gold cell in row 5. Which means none of these can contain a 5 because they're going to be the 5th cell in the column. And that would force it to be a gold cell. So this is 5, 6 is one of these, 7 is one of these, 8 is one of these, 9 is one of these, 3. 1's one of these, 2's one of these, 3's one of these, 4's one of these. That's 5. 6 is one of these, 7 has to be one of these 3. 8 has to be one of those 4, 9 has to be one of these. So let's start filling in what the possible digits for the gold cells can be. This is either third, so it's position 3 in the row, position 1 in the column, and position 3 in the box. So this is 1 or 3. This is 7, 1, or 4. 1, 2, 3, 4 in its region. This is 8, 1, or 1. This is 8, 2, or 1, 2, 3, 4. So all of these can have to contain a 2. Can be 3. Can be 4, 6, 7, and 8. These are all 9 as possibilities. These can all be 1. You have 2 as possibility. 3 here. 4 here. That's 5. This is 6 or 6. You have 7, 7, 7. 8 in this column. 9 in this column. And now we're just looking at position. So in the box, in the region. So 1, 2, 3. 1, 2, 3, 4. 1. 1, 2, 3, 4. Or this is 5, but it can't be 5 because of 5 in the column. This here is 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2. This is 1, 2, 3, 4, 5, 6. This is 1, 2. This could be 1, 2, or 3. This would be 4 or 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This digit can be 1 or... this would be 2. This would be 1, 2, 3, 4, 5, 6, 7, 8. This would be 1, 2, 3, 4. This would be 1, 2, 3, 4, 5, 6. Aha. This would be 1, 2, or 3. This is 1 and 2. This is 1 and 2. This is 1, 2, 3, 4, 5. This would be 6. That would be 7. This would be 8. That would be 9. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. So that's already counted there. We have a 4, 6, 8 triplet in row 6, which eliminates 4, 6, 8 in the rest of the row. So this cannot be 4, 6, or 8. Therefore, it's 2. This 2 eliminates 2 here, so this must be 9. So this can no longer be 2 in the rest of this row, or this column. This 9 eliminates 9 here, so this is 7, which means this can't be 7 here, this can't be 7 here, and this can't be 9 because of the 9 in the row. And this 7 eliminates 7 in the rest of its region, so this can't be 7 here. Okay. The remaining digits in row 6 have to be the odd digits. 1, 3, 5, 7, 9. Obviously, this can't be 9 because of the 9 in the region. 1, 3, 5, 7, 9. 1, 3, 7, and 9 because no 5 in the column. This can't be 5 in either of these spots because of the 5 in the region. So it's 1, 3, 7, 9. This can't be 7 because of the 7 in the column. 1, 3, 7, 9. Okay, so these white cells cannot be the cells matching their column, row, or position in the region. So this can't be 1. You can't have a 6 in the rows. This can't be 1 because of the 1 in the column. This can't be 3 because of the 3 in the column. I mean, it's in the third column. Can't be 5, no 7. This can't be 9. So now position in the region. 1, that's fine. This cannot be 7. This cannot be 9. Um, 1, 2, 3, 4. That's fine. 5, 6, 7. This can't be 7 because that's a 7th cell in the region. Okay, we have a 2, 9, 2, 9 pair in column 9, which eliminates 2 and 9 in the rest of the column, so this can't be 9, which makes this a 4. That eliminates 4 here, so this is 3. This can't be 4 because of the 4 in the row. This 4 eliminates 4 in the region, so this can't be 4 there. This 3 eliminates 3 in the column, and the 3 in the region. Okay. Okay, where is the 7? Neither of these can be 7. Where's the 7 in region 6? Neither of these can be 7 because they're white cells, and this is row 7, so it would have to match. So 7 in region 6 cannot be here because of the 7 in the column, so this must be a 7 here. And this can't be 7 because of it's the 7th cell in the region, and it's white. This is 7. Where is the 7 in column 9? Cannot be here because of the 7 in the region. Can't be here because 7 in the region. These are gold, and 7 never matches that. So 7 has to be one of these two cells. In region 1 and region 2, where is a 7? It's got to be in rows 1, 2, or 3. Because that's as far as the region extends to. So because of that, that means there's no more 7s in the rest of rows 1, 2, and 3. So this cannot be 7 here. Where's a 7 in region 4? Cannot be here, cannot be here, so it must be one of these 4. That means where is a 7 in region 5? Can't be here because of the 7 that's required for region 4. Can't be here because of the 7 already in region 6, so it must be in one of these 3 cells. It cannot be here because it's a white cell matching, that would be the 7th cell in the region. So this must be 7 here, which means this can't be 7 here. Where is the 7 in region 8? It cannot be here because of the 7 in the row. Can't be here because of the 7 in the column. Can't be here because it's a white cell in the row 7, which would mean that it would have to be gold if it were 7. So one of these two is a 7 here, which eliminates 7 in the rest of the column. I'm not sure if that's helpful, but where is the 7 in column 6? It cannot be here because of the 7 in the row, can't be here because of the 7 in the region, can't be here because 7 in the region, can't be here because 7 in the region, so it must be one of these three. Okay. Seven in region 7 has to be one of those three. Because this doesn't... Oh, wait, no, it's column... That is row 7. So that would have to be gold if that were a 7. So it's one of these two. Okay. Five. Where is the 5 in region 5? Can't be here because of the 5 in the column. Can't be here because of the 5 in the row. And it cannot be any of these because it does not match the gold cell, right? It would have to be the 5th cell in the row, which it's not because it would be in column 5, or the 5th cell in the column, which it's not because it would be in row 5, if that were the case. So none of these match 5, therefore the 5 has to be here. That 5 eliminates 5 here, so it's 3, which makes this 1 and 9. This 3 eliminates 3 in the rest of the region and the rest of the column. This is 1. The rest of column 9 has to be what? 3, 6, 7, 8, because of the 2, 9 pair in the column and the 4, 1, 5 already here. Where is the 3 in region 6? Can't be here because of the 3 in the column, and these are all filled out, and these don't match as a gold cell, so it must be here. So that's a 3. Remaining digits in region 6 are 2, 4, 6, and 8. Interesting. So 2 is one of these two cells. This is in row 5, column 7, so that doesn't matter for those. Same with this. This is in row 7, column 7, and it's the 9th cell. This is the first cell in the region. So again, in column 9, we have 3, 6, 7, 8 remaining. And obviously this can't be 7 because of the 7 in the region. Oh. This cannot be 3 because it's not gold. And it matches, it's in row 3. 1, 2, 3, 4, 5, 6. So this can't be 6. That's a 6 cell in the region. 1, 2, 3, 4, 5, 6, 7. So that's a 7th cell in the region, which means it cannot be 7 because then it would have to be gold. So that means in column 9, where is the 7? It has to be this. That eliminates 7 in the rest of the row. That's fine. Okay, this digit cannot be, so it cannot be 3, 7, or 9. It cannot be 2, so it could be 1. It's in the row 2, so that's why it can't be 2, and it's white. No 3. It could be 4. It can't be 4 because of the 4 in the region. It could be 5. It could be 6 or 8. This cell can't be 4 or 7 or 3. So 1, 2. 2 can't work because we are guaranteed one of these is a 2 in that region. No 3, 4. 5. 6. No 7. It could be 8 or 9, but it can't be 8 because it's in the 8th column. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. In this region 7, what are the remaining digits? We have 1, 4, 1, 4, 5, 6, 7, 8. But this can't be 4 because it's the 4th cell in the region. It can't be 7 because it's in the 7th row. That's it. This can't be first because it's in the first column. Can't be 7 because of the 7 in the row. Neither of these can be 8 because we are guaranteed one of these 3 has to be an 8. One, 2, 3, 4, 5, 6, 7, 8 anyways. The remaining digits in region 5. We have 1, 2, 4, 6, 8, 9. Okay. This can't be 1 or 4. 1 because of its position in the region, 4 because of the 4 in the row, and its position in the region. This can't be 4 because of its position in the region. Actually, no, this couldn't be... Yeah, I don't even know what I was saying there. This is column 4, this is row 5, and 4th in its position. This is 5. 5, 5, and 5. This is 6, so it can't be 6th. And row 5, position 6, so that's fine. Okay. Where is the 3 in region 4? Or actually in row 5. Can't be here because of 3 in the region. Can't be here because of 3 in the region. Can't be here because 3 in the column, so one of these is a 3. That eliminates 3 from being here. Well, we need a 3 in one of the gold cells in row 3. And so it has to be here. So this is 3. And actually, we needed that anyways. One of these is a 5, guaranteed. So 3 in column 9 has to be one of these 2 cells. That's fine. Okay. Where's the 4 in column 8? Can't be here because of the 4 in the box. This doesn't match as a gold cell. That's already filled out. So 4 has to be one of these 3 cells. Where? No, that's not true. Where are the 9s in columns 8 and 9? They have to be in these 2 cells. Or 2 regions, shall I say. Is that helpful? No. Oh, where's the 2 in region 1? Can't be here because of the 2 in the column. Can't be here because they're all white in row 2. And these don't match as the golden cell, so 2 has to be here. In region 1. In region 4, it's one of these 4, so that's pretty broad. Or these 5 cells. Ah! Where's the 2, though, in region 2? Can't be here anymore because of the 2 in the row. Can't be here because that's white cells. So it must be one of these 2, which eliminates 2 in the rest of the row. So this can't be 2. This is 4, which eliminates 4 in the rest of the column. Okay. Where's the 4 in region 7? The only place, it can't be here because it doesn't match the gold setting, right? So, and it can't be here because it doesn't match the gold, and it can't be here because it's white, and that would be 4 would force that to be non-white, so this must be 4 here. Where's the 4 in column 2? It cannot be here because of 4 in the region. Can't be here because of the way that the gold and the white regions worked. So it must be one of these 3 cells. Well, where's the 4 then in column 3? Can't be here because one of these 3 cells must be a 4. Can't be here because of the 4 in the region. This is filled out. These don't match for the gold cells, so the 4 in column 3 must be here, which eliminates 4 here. This can no longer be 4, and this can no longer be 4. Where's the 4 in column 8 now? It has to be here. So for region 6, the 4 has to be one of these 2 cells, which eliminates 4 as a possibility here because it sees both of these cells. We have a 6-8, 6-8 pair actually in row 6, which eliminates a 6 and 8 in the rest of the row. So this must be a 4, which eliminates 4 here. Where is the 4 in column 7 now? Can't be here because of the 4 in the region. Can't be here because 4 in the region. This is filled out. Can't be 4 because of the 4 in the row. And this can't be 4 because 4 in the region. So this must be a 4 here. Okay. That eliminates 4 from this cell and this cell. Where's the 4 in column 2? It has to be here. So that should be... Yes, we have 8 4s. So we know where the last 4 has to be. It has to be this cell. Okay. Where is the 1 in region 5? Can't be here because of it's a white cell and it's position 1. Can't be either of these because it doesn't match the gold cell positioning, so 1 has to be one of these 2. Remaining digits in column 8. We have 1, 2, 5, 6, 8, 9 as possibilities. This can't be 1. Neither of these can be 8 because they are in column 8 and neither are gold cells. This can't be 1 because its position in the region is 1. This can't be 9 because of the 9 in the row. Let's see. Where are the 5s in row... Where's the 5 in row 1? Cannot be here because of the 5 in the region. Can't be here because of the way that the gold cell works, and this is filled out. Can't be here because of the 5 in the column, so this must be a 5 here. Well, where's the 5 in row 2? Can't be here because of 5 in the region, can't be here because 5 in the region, doesn't fit for the gold cell here, so this must be a 5, which eliminates 5 here. Where's the 5 in column 8? It has to be one of these two cells, so it's in region 9. Where's the 5 in region 4? Can't be here or here because of the 5's in the row. Can't be here or here because 5's in the column. So it must be one of these two cells. This 5 eliminates 5 here. We have a 1, 6, 7, 8 quadruplet in region 7, which eliminates 1, 6, 7, 8 in the rest of the region. So this cannot be 1 or 8. This must be 5, which eliminates 5 here. Where's the 5 in region 4? It has to be here. We should have... Right, we have... Where's the 5 in region 8? Cannot be here, cannot be here because the 5's in the column. These don't match because of the gold cell, so it must be here. This 5 eliminates 5 in the rest of the row. Where's the 5 in column 8 now? It has to be here. Where is the 9 in column 8? Cannot be here because of the 9 in the region. Can't be here because of the 9 in the row. So it must be here because it's the only one that matches. That means this can't be 9. This is 2, which makes this 8, which makes that 1. This 8 eliminates 8 here, so it's 6. This becomes a 3-8 pair here. This 2 eliminates 2 here, so this is 9. This can't be 8 because of the 8 in the column, so this is 6, which makes this 8. That eliminates 8 in the rest of the region. This 6 eliminates 6 in the rest of the region. This becomes a 2-8 pair, so this cannot be 2. Where's the 2 again in region 2? It has to be this cell. So this is 2, which forces this to be 7. This 2 eliminates 2 here, so it's 6, which eliminates 6 in the rest of the region. This can't be 2 because of the 2 in the column. This 1 eliminates 1 in the row, so this is 3. This 3 eliminates 3 in the rest of the column, so it's 6. This 6 eliminates 6 in the rest of the row, so that can't be 6. The rest of the digits in region 9 are 1, 2, and 6 because of the 3-8 pair here. So 6 has to be one of these two cells, which eliminates 6 in the rest of the row. This can't be 6, therefore this is 8, which makes that not 8, so it's 7, which makes this not 7, so it's 1, which eliminates 1 here, so it's 6. 1 eliminates 1 here, so it's 8. Okay. Remaining digits in column 1. Actually, let's do remaining digits in row 1. It's 6, 8, and 9. This can't be 8 because of 8 in the column. This can't be 6 because of 6 in the column. The remaining digits in region 2 are 1 and 3. This can't be 3 because of the 3 in the row and the column, so this is 1, which makes this 3. Remaining digits in row 3 are 7 and 9, and this can't be 7 because one of these must be 7 here. This 9 eliminates 9 here, so it's 2, which eliminates 2 here, so it's a 1, 9 pair here. Remaining digits in row 4 are what? 1, 7, and 8. That eliminates 1, 7, and 8 in the rest of the region. This can't be 1 or 8, so this is 7, which eliminates 7 in the rest of the region. This can't be 7, so it's 9, which makes that 7. This 8 eliminates 8 here, so it's 1 and 8. This can't be 3 because of 3 in the column, so this must be 3 here. The remaining digits in row 2 are 1, 6, and 9. And this can't be 1, so this is 6 or 9. This can't be 6 or 9, so it's 1, which forces this to be a 6 or 9 pair. We have a 6, 9 pair in column 4, which eliminates 6 and 9 in the rest of the column. So this cannot be 9. This is 1, which makes this 9. The rest of row 5 has to be 2, 6, or 8. And this cannot be 2 or 8. So this is 6. This can't be 2, 6, or 8. So this is 2, which makes this 8, which makes that 2. Which means this can't be 2. That's 7. So this can't be 1 or 2. So that's 6. This can't be 2 or 6. So this is 1, which makes this not 1. So that's 2. This 8 eliminates 8 here. So it's 3 and 8. Remaining digits in column. This 6 eliminates 6 here, so it's 9 and 6, which forces this not to be 6, so it's 9. Remaining digits in column 4 are 2 and 3. This can't be 3 because of the 3 in the row, so this is 2, that's 3. This 9 eliminates 9 here, so it's 8, which forces this not to be 8 or 9, so it's 6. That leaves this digit as 8, this digit as 9, and this digit as 1. And that's the solution. Fairly straightforward. You just have to basically... Yeah, it's just basically irregular Sudoku, or Jigsaw Sudoku, as Alf is putting it. Which some people aren't used to, but it's not that hard. You just go through and eliminate possibilities, and it's pretty straightforward. Anyways, I hope you enjoyed the solve today, and I'll see you next time on Frank Puzzles. Take care.